send this to my... All right, the question is, where is it? The deca, right here. So the question is, a decagram is blank times as large as a nanogram. And the answer is 10 to the blank power, right? All right, so a decagram is 10 to the first power, and a nanogram is 10 to the minus 9 power. So even if you use the chart, this guy, it goes out further. You would move 9 units to get to the gram, right? So 10 to the minus 9 is 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8. That's 9. But you need to go 1 more unit to get to the, because that's at the 0 part. You need to go 10 units. So this should have been 10 to the 10th power. Let me know if that, did you plug it in? Is that what I gave you? So it's 9 units to level it out as a positive 10. But then you need 1 more unit to level it out at 0, to just give you grams. Then you need 1 more unit to get to the deca. So it's 9 plus the 1 is 10. Yeah, you add the absolute values. Any other questions? I'm going to talk about some of the blood alcohol content and and some of the, I'm going to talk about the blood alcohol content and like some medicine dosages to help with some of the problems. Anybody else before I do those? Okay. All right, so the blood alcohol content is actually, well, I'm going to talk about density. It's actually these three examples: the densities and the medication doses, and then the blood alcohol content for the hard liquor. So example 8A, compute the following densities using appropriate units. A block of oak has a volume of 200 cubic centimeters and weighs 0.12 kilograms. What is the density? Will it float in water? Well, material density remember, is grams per cubic centimeters. That is the units for material density. It's grams per cubic centimeters. So if it says we have cubic centimeters already, 200 cubic centimeters, no problem. We don't have to do the conversion on that. We already have cubic centimeters. But the weight is 0.12 kilograms. So we got to convert the kilograms to grams first. This is 2B. It's still in 2B. Yeah. Right after the temperature stuff. Kilograms to grams. So I have 0.12 kilograms. I need grams. And we have kilograms. So it's 1,000 grams in 1 kilogram. Kilograms cancel. So this gives me 120 grams. Density is grams per cubic centimeters. As a division problem. Grams go on top. So I have 120 grams over 200 cubic centimeters. And then divide it. 200 or 120 divided by 200. So this is 0.6. Don't do this to me. Yeah, 0.6 grams per cubic centimeter. Questions on that? Similarly for B, you have to convert ounces to grams and cubic inches to centimeters. C, we did something similar last time. This is the population density. Remember that this is people per square mile, per mile squared. How many people per square mile? And then D is storage space. Number 9, medication doses. Suppose a penicillin dose of 9,000 units per kilogram of body weight taken every 6 hours is prescribed for treatment of a bacterial infection. For penicillin, 400,000 units is equal to 250 milligrams. Express the dose in milligrams per kilogram of body weight. All right, so there's a couple options for this. I chose to do this problem probably a little bit more complicated. I'm like, I have 9,000 units per kilogram. So, well, how many milligrams are in 1 unit? And then I can figure out, or how many units is 1 milligram. Then I can figure out the 9,000 units part. And that's exactly what I did. 400,000 units is equal to 250 milligrams. 400,000 over 250 gives you how many units in 1 milligram. So I did the 400,000 divided by 250 gave me 1,600 units per milligram per 1 milligram. And that took care of this guy. That got rid of that data info. Well, 9,000 units per kilogram. Well, if 1 unit, or if 1,600 units is 1 milligram and I have 9,000 units, then how many milligrams will I have? Well, I did the 9,000 divided by 1,600. That'll give me units, that'll give me milligrams per kilogram. So 9,000 divided by 1,600 is 5.625 milligrams per kilogram. So 5.625 milligrams per kilogram. That takes care of the first part. Now, part B, how many milligrams of penicillin would a 20 kilogram child take in one day? Well, it's every 6 hours. How many times a day if it's every 6 hours? 4. So 4 times 20, because that's the kilograms, times 5.625 gives us how much? 4 times 20 is 80, times 5.625 is the 450 milligrams. Any questions on that? No? Are we good? All right. Blood alcohol content. So, quick question beforehand. What is the legal amount of BAC allowed to drive? What must, without getting a DUI? All right. I think when I look, it's close. You have to be under a 0.08. Just keep this in mind for part of this question. If you, or is it a 0.08? I think it's 0.08 or higher, you can get a DUI. So I think it has to be below 0.08. All right, so let's talk about this blood alcohol content of hard liquor. 8 ounces of hard liquor, such as whiskey, typically contains about 70 grams of alcohol. Consider a 180-pound man with approximately 6 liters, which 6,000 milliliters of blood, who quickly drinks 8 ounces of hard liquor. If all the alcohol were immediately absorbed into his bloodstream, what would his blood alcohol content be? And then explain why it is fortunate that in reality the alcohol is not absorbed immediately. Okay. Blood alcohol content is grams per 100 milliliters of blood. This is the unit for BAC. Um, 70 grams of alcohol, no problem, already in grams. 180-pound man, yeah, it's just additional information. We don't really need that. Approximately 6 liters, 6,000 milliliters of blood. Well, we need this because it's milliliters of blood we need. But it's 6,000 milliliters. This is grams per 100 milliliters. So let's condense the 6,000 and get it to 1 milliliter. So 6,000 milliliters divided by 100 gives me 60. 60 milliliters. Now I can do grams per milliliter, which is 70 grams per 60 milliliters. Grams, which gives me a 1.167 grams per milliliter alcohol content. I mean, it's kind of a lot. So explain why it is fortunate that in reality the alcohol is not absorbed immediately. What is the BAC level for death? Somebody look that up on Google. If 0.08 is illegal driving, 0.08. All right. So 0.4 is dangerously fatal. All right, so having a 1.167, that's assuming that it's all absorbed in one sitting, is a lot. If 0.4 is dangerously fatal. So, fortunately, the alcohol is not absorbed immediately, right? It takes time. It takes time to travel. So, the next question is, assume that all the alcohol is absorbed immediately, but the man's body then eliminates the alcohol through metabolism at a rate of 15 grams per hour. What is his blood alcohol content 4 hours after drinking the liquor? Is it safe for him to drive at this time? 15 grams per hour in 4 hours. How many grams is that? 60. So we started with 70. We lost 60. And now we have 10 left over. 10 grams left over after 4 hours, right? So 10 divided by 60 gives us 1/6, which is, I should know this, 1 divided by 6 is still 0.167. Can he drive home yet? No. Right, because the legal limit is 0.08. Yeah. Keep drinking water. A lot. Hopefully this helps just a little bit for those BAC problems, because some of them were a little hard. And the medication dosages. Currency, we've done this already. We did some of the currency. Here's some more of these. Let's do 14. This is a good example. The label on a particular drug recommends 75 to 150 milligrams of the drug per kilogram of body weight per day. A doctor prescribes 200 milligrams of a drug every 8 hours for a 20-pound child. Is the prescription within the guidelines? All right, so we got to find the range of acceptable milligrams per day based on the 75 to 150. So first thing we got to do is we need 20 pounds in kilograms. So I have 20 pounds. I need kilograms. I have pounds. So is it kilograms in pounds or pounds in kilograms? It's what? I think it's 2.2 pounds in a kilogram, right? 2.2 and 1 kilogram. So this is pounds cancel. This is 20 divided by 2.2. 20 divided by 2.2. It's 9.09, so let's just do 9.1. We're going to round up. 9.1 kilograms. Okay, let's start with the minimum value. The minimum. 75 milligrams per kilogram. So the minimum is 75 milligrams per kilogram. So times 9.1 kilograms. Total per day. So total minimum is 682.5 milligrams. Okay. Maximum 150 milligrams per kilogram times 9.1 kilograms. Remember, these units cancel. Gives me 150 times 9.1. 1,365 milligrams per day. That's the maximum. Minimum amount, maximum amount. Based on a 20-pound child, which is 9.1 kilograms. Because everything's by weight. Everybody with me so far? That's just a normal weight calculation. All right, the doctor prescribes 200 milligrams of the drug every 8 hours. How many times a day if you take it every 8 hours? And 23, right? And what's 3 times 200? So the doctor prescribes 600 milligrams per day. Is that within our range? No, it's below. So he didn't do enough. This is our minimum, and this is our maximum. So the amount per day has to be between these two amounts. Questions on that? You got it? Okay. Everybody else got it? Good? Okay. Some more example problems if you want to look through them. I'll probably post some solutions online to kind of help with the examples, solution concentrations. Yeah, I'll post those online. Unit 2C, problem solving, because this is definitely the homework that's due this week. Hints and guidelines. Okay, so there may be more than one answer. That's okay. We got more than one answer. There may be more than one method. Some of you probably did some of those problems backwards from what I did on. Like I went from a single unit versus doing multi-units. Or I did milligrams, single milligram, where you guys might have done single units. Use appropriate tools. Consider similar problems. Consider equivalent problems. Approximations can be useful. Try alternative patterns of thought and do not spin your wheels. So here is the first example. The toll booth. All right. And the questions in the homework, you have to select all that apply for the multiple answers. But these have multiple answers. A toll collector on the highway receives $2 for cars. So let's say 2x. And $3 for buses, plus 3y. And at the end of the hour, she collected $32. How many cars and buses passed through the toll booth during that period? List all possible solutions. So if she had one car that takes away $2, then how many buses would she have? 10, right? 10 buses. That's one solution. What if she had 2 cars? How many buses will she have? Two cars. Two cars at $2 a piece is $4, right? 6. 32 minus $4 is $18. So how many cars can you get or how many buses can you get if each of them is $3? So 2 cars is 6 buses. Give me another example. You can have all cars and no buses, right? All cars would be 16 cars and no buses. You can't have the other way around though, because it's a fraction. What if I had 4 cars? How many buses would I have? So 32 minus 8. Yeah, 8, right? 4 cars and we have 8 buses. How many possibilities do we have? Any more? Do we have any more? What about 5 cars? 5 cars and 4 buses. All right, so we get the point, right? There's a bunch of possibilities. Multiple answers. You just have to problem solve through this. These are similar problems. They're asking for multiple solutions. Let's talk about perimeter and area. So perimeter, what is the formula for perimeter? You guys remember? Perimeter? Yeah. Plus 2W. Perimeter is how much of the baseboard you need to line up the room, right? How much of it am I going to get, or do I need to go all the way around the room? What about area? What's the formula for area? Because it doesn't give it, this is either 2, length times width. Area is how much tile I need to cover the floor, the inside. Perimeter is all the outside. It has to do with fencing or the edging, lining the walls. And area is inside. Tiling, sod, grout, whatever you need. Area is inside. So these questions are also going to ask, well, is similarly different shapes and size, different dimensions of perimeter, different dimensions of area, similarly to what we just did with the toll booths. There are multiple answers. But these are the 2. What's volume? One time. Right. Volume equals length times width times height. These are the 3 formulas they do not give you on the test. Okay. They'll give you the conversions, no problem. But these are the 3 that are not on the test. So you don't have to memorize the crazy conversions, but these 3 you need to know. Fencing a yard, common error. All right. Moving up. Percentages. 3A. All right, let's talk about percents real quick. Percents is per cent, means per 100. So, yes, ma'am. Oh, I'm sorry.
Yeah, you said 2C was due this Sunday?
Yeah.
It says 922.
Are you sure it's that one open?
Yeah, it says 922.
Okay. Well,
And chapter 3 is 926.
that integrated review is 926.
Okay.
That chapter 3 quiz review, it eliminates homework from chapter 3 integrated review. And that's like the basic math stuff, fraction, and then percentages. It should be the basic math to see what you know, give you some practice for the pre-knowledge you're supposed to have.
Yeah.
I'll check on 2C.
Yeah.
Okay.
I did it.
Because 2C quiz isn't due till this week either. Right? Yeah, because the quiz 1 was only on A and B.
Yeah.
Yeah, so it shouldn't have been due. Okay, I'll fix it. I'm sorry.
It just says 2C, 22.
Okay. Is this closing on the 22nd or opening?
It says close.
Okay.
Closing.
Okay, I'll fix it. Okay. Percent is per 100. To go from decimal to percent, there's 2 options. Well, let's just do one option. 0.125. Move decimal 2 spots to the right. Add percent sign. So 2 spots to the right. 2 is 12.5%. to go from percent to decimal, this is where we have the two options. So we can either go the other direction, 12%, move the decimal 2 spots to the left. If there isn't one, you put one at the end. 1, 2, and this becomes 0.12. Or put the number, here's option 2. So here's first option, here's option 2. Put the number over 100 every time. Put the percent over 100. So this will be, let's say 30%. This will be 30 over 100, which is 3/10. Then divide it out, 0.3. So this does two things for you. One, it goes from percent to fraction and to decimal. So you get all three of the conversions. And it'll always divide out. I've had students in the past, they'd be like, oh, 45%. And I don't know, they put some magic number right here, and then they go 1, 2, and I don't know what happens. So the moving the decimal probably isn't the best solution, but if you are quick with it, you know you can move it. You know that 45% is 0.45, no problem. Simple conversions. Some words of caution about percentages. I don't want to say you can't add or subtract them, because you can, but we like to use the decimal or the fraction notation first. However, you cannot multiply or divide the percent. So you have to convert to a decimal first. So no multiplying or dividing percentages. It leads to like skewed results, larger than normal percentages. For example, 25% and 75%. If we were to multiply these, 25 times 75, this is 1,875%. This just doesn't make sense. You just can't do that. 25% is 1/4. 75% is 3/4. When you multiply these normally, like in the fraction, you get 4/16, right? Or 3/16, sorry, just kidding. 3/16. And this is actually 0.1875. Or so 18.75%. So be careful when doing that. You can't multiply the percentages by themselves. It gives you a huge number and they're skewed. You have to convert it first. All right? Any questions on that? Okay. Let's go back to this guy. To find the percent or the decimal from the fraction, like this guy, this is written in the calculator as 2 divided by 5. It's 2. That's what a fraction is. It's a division problem. It's the top number divided by the bottom. So 2 divided by 5 is going to be 0.4 or 40%. %30 is 0.3 or 3/10. Or 30 over 100, and then it reduces. 3/10. 7.5 is 750%. Or 750 over 100, which gives us 75 over 10. Percents as fractions. Express the first number as a percent of the second number. So it's going to be the first number divided by the second number. So the full-time year-round median salary for the U.S. workers in 2000 was 30,846 compared to 52,800 in 2020. Just by looking at those two numbers, it should be over what percentage? When you do the math, 50, right? It should definitely be over 50%. Because what is 50% of 5,200 or 52,000? 26, and 30 is bigger than 26. So it could, just by visualizing and thinking of halves, you could see where your answer should lie. But this is 30,846 divided by 52,800.
Question.
Yes.
For A, I see that you stated 2/5.
Yep.
Equals 40%, right?
Yeah.
But there's another number. Is that just a four? Like a like just 4 by itself?
This guy?
Oh, 0.4.
0.4.
All right, I see. Okay.
Yeah, 0.4 is 40%. I know, I'm sorry, the work to do this is so small. I'm sorry. This is 0.584. We'll leave it like that. 58.4%. Division problem. These are just division problems. That's it.
So this is what this week's homework is gonna be.
It should be some of it. This is 3A actually.
Okay.
2C is
Yeah.
some problem solving, like some tricky, like what are they called, the mind teaser, what are they called, what are this,
Okay.
I don't want to say like trick questions.
Yes, these are trick questions.
They're not trick questions, they're
Your brain.
brain teasers. Thank you. Yeah, so there's a lot of brain teasers in 2C. Does it make sense or not? This is this is 3A. Yeah, percentages. The rest of these example problems are very similar. And then let's talk about absolute change and relative change. Okay. This is similar to percent of increase and percent of decrease. They just use bigger words. It's similar. The absolute change is going to be the actual change, increase or decrease. The numerical value. So if the population was 20 million yesterday and it's 25 million today, then there's a $5 million or 5 million person increase. It's 5 million is going to be the absolute change, like the actual number. So this will be the new value minus the reference value. The relative change is going to be the percentage. Okay, so this is going to be that 5 million you got for your actual value. So your actual value over the original value or the reference value. Right, so it would have been 5 million over, what was my original? What did I say, 20 million? And then you would make it a percent times 100%. Or times 100, add the percent. Got it? We're good? Okay. Here are some example problems. The estimated number of refugees in the world increased from 8.7 million to 2005 to 26 million in 2020. Find the relative and absolute change. So I'm going to do the absolute change here. Let's call it AC. Absolute change is the actual numerical value. So this is going to be 26.0 minus 8.7. This is 17.3. That's the absolute change. Now, what about the relative change? Let's call this RC. Well, this is going to be your absolute change, which is 17.3 over the reference value, which was the original value, which is what? That's in 2020. What's the original year? 2005. So 8.7. The original amount, 8.7. $17.3 divided by 8.7. This is approximately equal to 1.99 or 199%. Does that make sense? Well, 100% increase would be what? Another 8.7. So 8.7 and 8.7 would have been 17.4. So that's 100%. Well, it's greater than 17.4 for sure. Good. Similar problems, they're the same. Percents for comparison. Absolute difference. This is going to be the compared value minus the reference value. The relative difference is going to be the absolute difference over the reference value. Times 100%. All right, next problem. The life expectancy at birth of all Americans in 2020 was 78.6 years. Is blank percent greater than the life expectancy of all Americans in 1900, which was 47.3 years. Well, what's the absolute difference? Let's call this AD. This is 78.6 minus 47.3, right? Just 31.3. The RD is 31.3 divided by 47.3. which gives us 0.66, which is 66%. So the life expectancy, yes, ma'am.
So I had a problem I don't know if it was like this, but anyways, the answer was like 6 for like infinity, but it was like round up or whatever. So I put 0.66, and it was like, no, you got the answer wrong. This is actually 0.67. And I'm like, what?
Would be
You have to like round up or whatever.
only if it's okay. 0.666666 dot is 0.67.
But it didn't specify that.
You have just because you have to knock off this infinite value of sixes.
Okay.
The one I just divided by was 0.661 some change. I'm like, okay, I'm dropping that guy off. It's 0.6. It's 66%. There's a difference. This one ends versus this one doesn't. When it doesn't, you round up that second number to the next highest number to round it off.
There's some of the questions I'm getting
Yeah.
paid, like, I'll be off by like 1
Because you're not rounding. Yeah. The infinite, the repeating, they round up 1 on the second decimal. Or whatever decimal it tells you to round to. So this one says hundredths. Round to the nearest hundredths. You're going to round that one up to 7. Yeah. So this guy is 66%. Yeah. I got sidetracked. 66%. So the relative difference is 66% of the original one to determine more than or less than. So for more than, it's that percentage plus 100, because that is how much more than the relative number, the relative value is. This will be 166% greater than the life expectancy, which makes sense. What is 100%? Another 47.3. Yeah, it's close. 47.3 plus. Yeah. For the less than, it would be 100 minus the percentage. So whatever you got here for your percentage, you do 100 minus. 100 minus that percent. Any questions on this so far? We'll come back to this next time.